Example 3 of using the shell method to find solids of revolution. In this example we have two parabolas, one that's opening upward, one that's opening downward. We want to rotate it about the line x equals 8. And so you can see my graph. I've got this parabola opening downward, this parabola opening upward, and I found these points of intersection. A simple way of doing that is simply set the two equations equal to one another and solve. And I found that would be x equal 1 and x equal 5 would be the two places where the parabolas intersect. So using the shell method, I start off with the volume equaling 2 pi, the integral from x equals 1 to x equal 5. Those are the 2 points of intersection. And then I called this radius. If I'm here at this line x equals 8, my radius would be the distance from here over. So it would be 8 minus x. So here's my 8, and then minus x is whatever from wherever I start to wherever I end. And notice how my finger is doing this. I'm standing here at 8, and then from the origin I have 1 and 5. So I'm going to do 8 minus whatever value, 8 minus whatever value, 8 minus whatever value that goes from 1 to 5, which puts me in this region. So that's why I say 8 minus x. And then the height would be the parabola that opened downward minus the parabola that opened upward. And that's what you see right here. The downward parabola minus the upward parabola. As I've said so many times, be careful of your subtraction because that negative gets distributed to all three parts. Now as I distribute that, negative x, take away x squared would be minus 2x squared. 6x minus a negative 6x would be plus 6x, so there'd be 6x and 6x is 12x. And negative 1 minus 9 is negative 10. So I simplify it, and I get this 2 pi, the integral from 1 to 5 of 8 minus x, that's my radius, and here's my height. Now you can put that in the calculator. As I put it into my calculator, I got 670.206. So that's how I set up this situation using shells. It was 2 pi, the integral from 1 to 5, the radius was 8 minus x, and then top minus bottom. And that's how I come up with this right here. That's our third example for the shell method.